Okay, this will be the solutions for our Newton's third law worksheet. Now, in class, you all were supposed to come up with a demonstration of Newton's third law and then explain it to the class. I'm going to go ahead and explain one that I would have used if I were in your shoes. So, let's say we've got two people, and each person is going to sit in a rolling chair. So, we have a rolling chair, the person with very long arms, and another person in a rolling chair like this. And the person on the right, the person on the left is going to push the person on the right, but when he pushes off, each person moves away from the other person. So our little third law of force pair, the push acts on each one of them. That's our equal and opposite force. So the push acts on each person there, and they both move even though one person's actively pushing, because that push exists as a pair of forces between them. One of those forces acts on the chair to the right, the other force acts on the chair to the left. Those two things constitute the entire force. All right, so the thing that you all memorized in third grade was the third law of motion states that for every action there's an equal and opposite reaction. Explain this phrase using common language. So a couple ways that we could say this, I think. Every force is made up of a pair of identical forces acting between two objects. That is Newton's third law. If I'm one of the objects, push, that's one of the pairs of forces. I push the wall, that's my other object, the wall. The wall pushes back on me. So that's how we would talk about that action-reaction pair. As soon as I touch the wall begins touching me. As soon as I begin pushing on the wall begins pushing back on me, and the wall will always push on me as hard as I push it. So if we're sitting there stationary and I'm pushing on the wall pushes back on me with the same force. If I am in a rolling chair pushing on the wall, and I go backwards, the wall is still pushing on me just as hard as I push on the wall. The reason that I move is because the force on me is a net force and it causes me to move. It does not matter that I'm applying a force to a wall. All that matters is that the wall is applying a force to me. And the only thing that determines my motion are the forces acting on me. That's what's great about the third law. It does not tell us about motion. It tells us about this specific force pair. It can't tell us about the motion of one object because third law force pairs each act on different objects. So in the example we just did, I am one object, the wall is another object. For half of the pair, the force acts on the wall. For the other half, the force acts on me. But it's acting on two different objects. So, a reaction force is the push back, just like we talked about, and will always be equal in magnitude to the action force. Always. Regardless of if there is motion or not, regardless of if one object accelerates or both objects accelerates, the reaction force always has to be equal to the action force. It's the law. That's how it works. Okay. So number 4, we have an astronaut on a spacewalk. And the rocket pack is no longer working, and he's stranded 50 meters away. How can he use the pack to propel himself back towards the ship? So here's what he should do. If he throws the pack, so if he throws his rocket pack away from the ship, he will move towards the ship. So if we look at this in terms of Newton's laws and what's going on with the forces, the astronaut pushes on the pack. The pack pushes on the astronaut. So when the astronaut pushes on the pack, that's my action force. The reaction is that the pack pushes on the astronaut. And that reaction causes the astronaut to move back towards the spaceship. So 2 astronauts play catch. So when an astronaut catches the ball, the astronaut pushes forward on the ball, which stops the ball. But the ball, as the reaction, pushes backwards on the astronaut. This causes the astronaut to move backwards just a little bit. For the throw, the astronaut pushes back. He pushes the ball forward, rather. This makes the ball move forward. The ball pushes back on the astronaut, and the astronaut moves backwards. So what's going to happen is that these astronauts slowly separate. Each time they throw the ball, they move backwards. Each time they catch the ball, they move backwards, and they separate as that happens. All right, number 6, there is a little fender bender where a semi-truck bumps into a Volkswagen. Now, I want to know about the magnitude of the force exerted by the Volkswagen on the truck. I want to know if that magnitude is greater than, less than, or equal to the force that the truck exerts on the Volkswagen. So, this is an action-reaction pair. The action is the Volkswagen pushing on the truck. The reaction is the truck pushing back on the Volkswagen. Same force between the same 2 objects, it must be equal and opposite. So the forces must be equal and in opposite directions. So if we look at a little picture of what's going on, we've got the VW careening into the truck. The VW applies a force to the truck. That's the force from the VW on the truck. And then the truck puts an equal and opposite force back on the VW. That's how that action-reaction pair works. Why does a basketball bounce up when it's dribbled against the ground? So looking at this, the action force is the basketball pushing down on the ground. The reaction to that is the ground pushing up on the basketball. And as far as the basketball is concerned, the upward force causes the basketball to bounce, to move up. That's what causes it to move, because there's an outside force from the ground moving the basketball. All right, we've got Johnny and Mary on ice skates on a frictionless sheet of ice. While facing each other, Johnny pushes Mary so that she accelerates. What's Johnny's acceleration? So, when Johnny pushes on Mary, they both experience the same size force. So the force on Johnny is the same as the force on Mary. The third law says that those forces are equal. Well, mass times acceleration is what that net force is equal to. And so Mary's mass times her acceleration is equal to Johnny's mass times his acceleration. So 80, Johnny's mass, times his acceleration, which we don't know, is equal to 60, Mary's mass, times her acceleration, which is 4. So 80A is equal to 240. Divide both sides by 80, and that acceleration comes out to 3 meters per second squared. Now notice, they have the same force acting on them, but because Johnny is more massive, he experiences a smaller acceleration than Mary, even though they have the same force. All right, number 9, a rocket works by pushing gases out of the rear end of rocket. Explain how this causes it to be propelled forward. So the action in this situation is the rocket pushing gas out. The reaction is the gas pushing the rocket in the other direction, so forward. The gas pushes the rocket forward, causing it to accelerate.